This is an Extron composite video distribution amplifier. Oh, I see on the bottom there's instructions. I bought this about a year ago. I think less than $20. Alright, it's 75 ohms, 30 megahertz band pass. In any event, I intend to use it to distribute my 10 megahertz reference signal. And it's got 6 outputs. One input. This is extremely clean. Weighs about 3.5 pounds. Of course, it's 75 ohm in and out right now. And I don't think that mismatch, if I leave it at 75 ohms, I don't think it's going to hurt a damn thing. There we have it. So the power supply is mounted on the top cover. It's hung from the top cover. As switching power supplies go, it looks pretty nice. Looks just like a plus or minus connection here. And they connect to this board, which has almost no components on it. You see the case is raveted out, front and rear, to accept this metal plate. It's very nicely made. So what's happening here? No heat sinks. The date of 2000 on it. This is an input. Apparently this is an amplifier. It's an EL2099. The output apparently just passes through these resistors, which are 75 ohm. And we go into the BNCs. You can see these traces here, 3 of them. This is a 75 ohm input resistor. So if I wanted to, I could change all of these to say 51 ohm resistors. However, I think I just reassemble it now that I know what I'm looking at, and see whether 75 ohm output makes any difference, any practical difference. This is the space that was formerly occupied by the B&K signal generator. I now have replaced it with the QRP Labs signal generator, a QRP Labs reference generator, which is the same thing, except it does not have the low-pass filters, and I intend to keep it set at 10 megahertz. This is a QRP Labs clock. The date, time, down to the second in GMT. I'll probably reset that or put a second line that's corrected to Eastern Standard Time. And this is the video distribution supply. So what I'll do is take this 10 megahertz standard clock, whatever, and input it to this unit. I think I'll move one of the BNCs to the front of this, so I have a 10 megahertz output available to me. And then I'll use the other outputs to connect to various things in the shop. So the shop will entirely run on this 10 megahertz standard. Now right below here, okay, I'll pan down, and you see what we have? That's my oscilloscope. Right now I have the yellow input is from the standard, I call it. The purple input is from the QRP sine wave generator. They're both at nominally 10 megahertz. This is the native output from the generator, the yellow. And here is the output from the low-pass filter. You see how clean it is? Now they're moving relative to each other. It's because the standard is set to 10 megahertz. This blue line is set to 9999996 megahertz. So they're about 4 cycles at 10 megahertz difference. I don't know which is correct or whether they're both wrong. It's 4 hertz lower than 10 megahertz. I'll increase it 1 hertz. That is, I'll bring the two 10 megahertz nominal devices closer together. And you see it moves. And I'll take it to 6 hertz. So you can see 6 hertz moves it this way. 5 hertz slows it down. And 4 hertz moves it that way. So we're very close to 5 hertz difference. And they've both been powered up for about 4.5 days. Well, this is what I did. I routed the output from the 10 megahertz generator, routed it into the video distribution system. And there's something wrong with it. So this explains what I thought was the heartbeat. Switching power supply is switching on and failing, on and failing. I used this little device tester and a male by male DuPont, one end in here, and I touched on the different capacitors and measured them. This fellow, according to the markings, is installed backwards, but I replaced it and installed it backwards, exactly the way I took it out. That didn't fix the problem. This did. They're both 100 microfarad. They were 25 volts, so I made them 35. So with the replacement of this capacitor, the board works again. So here we go, the distribution amplifier is back up and working. I put an output on the front. I marked that output that corresponds to the front red. I was going to take it out, but this is one of those really good, would have been too much work. This comes from my standard. I have 16 dB of attenuation inserted. Probably too much. Here we are looking at the output from distribution amplifier. I don't know if you'll see this in the camera, but this is 0.6 volt peak to peak, which is about what the 16 dB of attenuation gave me as the input to the distribution amp. So I may look around for a couple of smaller attenuators. But that being said, I think this will work fine. The distribution amp is only rated 1 volt peak to peak.